Our planet was created from fragments of the universe. Then life was born. It would grow, expand, and survive, often being sustained by the planet itself. Life kept expanding its frontiers, but most would branch away and fade into extinction. Until finally, one would survive to look out upon the universe and wonder what role it would play in the race for life on the miracle planet. "55 million years ago, dinosaurs had vanished into extinction. The world was left to mammals. It was still a restless Earth. Forces deep within were at work. In 2003, scientists from the University of Oslo discovered strange formations on the bottom of the sea off the coast of Greenland. They found some 800 holes, almost as if they had been drilled. They were about 2.5 miles deep, and they have been dated to 55 million years ago. The continents were still being shunted across the globe. Slowly and steadily, powerful forces were at work under the Earth's crust. The continent of Europe began to break away from what is now Greenland. Deep within the sediment of the seafloor, vast reserves of methane hydrate, a highly flammable gas, lay frozen. When warmed, the gas breaks from its bond with oxygen and gushes to the surface. When exposed to air, methane spontaneously ignites. Flames thousands of feet high blasted into the sky. It's a very efficient greenhouse gas, and the world went into another phase of warming. This period lasted about 5 million years, and once again the planet was transformed. Here in Oregon in the United States, one of the changes brought on by the warming is plain to see. For Dr. Robert Sussman of Washington University in St. Louis, this is a place of fascination. Embedded here in stone is the first angiosperm, the broad-leafed flowering trees so common on Earth today, the oaks and maples and alders.
This is a katsura tree that lived probably 44 million years ago. And it's about 25 meters tall and had a wide canopy. What we assume is that once the dinosaurs disappeared, that the angiosperms were very low and very small. And then, because of global warming, they became larger and larger. And this made an ideal environment for primates to evolve.
Our ancestors, the primates, which grew to become monkeys, apes, and humans, still lived in the shelter and safety of trees. The branches of these new flowering trees grow out and across each other as they compete for sunlight. The primates now had new surroundings to live in. Food resources became more plentiful. Many primates still live in the broadleaf forests of the world.
They could take advantage of all of the resources, mainly the fruit and the leaves, and also they didn't have to worry about the terrestrial predators. Find places to sleep and basically live in the trees. It developed a whole new environment for them.
But living in tall trees does require good eyesight. Our primitive ancestor, Carpolestes, lived in the short trees of early forests. As the new broadleaf forests grew, another primate appeared. This one, Shoshonus, had radically different eyes, now facing forward. While the planet stayed warm and humid, the broadleaf forests were able to spread into higher latitudes. As they expanded their range, so too did the early primates. But the expansion was to be short-lived. Forces were still at work to make the climate change yet again, this time from the south. Today, Antarctica is a frozen continent covered by ice and glaciers. When Greenland and Europe were wrenched apart, the result was global warming. When the change came from the south, it was to be cold. Antarctica was part of the large continent Gondwana, joined to South America and Australia. Then, it had a temperate climate. The continent was warmed by currents that flowed down from the equator, much as the Gulf Stream warms parts of the north today. Antarctica became isolated as Gondwana was torn apart. Australia and South America drifted north, and the circumpolar current encompassed Antarctica, locking in the frigid air. Antarctica froze, and the world changed. Temperatures which had been kept high because of the methane released from under the sea now plummeted. The broadleaf forests retreated. Primates were left stranded in pockets of forest before they too vanished. This area of the Sahara to the west of Egypt was once forest. Then it became a remnant patch before it turned to desert. Dr. Yusri Atiyah of the Egyptian Geological Museum searches for the remains of the primates that once lived here. And they are all around. So far, over 22 different species have been identified from the remnants of their jaws or skulls. One of the early primates that lived here is an ancestor called Catopithecus. When its skull was found in 1992, it stood out as being unique. The eyes are completely different to those of other primates of the same period. When the two skulls are compared, the eye sockets of one have no backing, while those of Catopithecus do. The bone behind the sockets is called the post-orbital septum. While it may seem unimportant, it was a crucial step in the evolution of primate eyesight. This feature is shared by many modern primates. Gibbons have it, so do chimps, and so do we. But how would this be important for primates? To find the answers, you need to study the eyes, something that Dr. Callum Ross of the University of Chicago has been doing for years. He is an expert in primate eyesight, especially the significance of the post-orbital septum.
Post-orbital septum evolved because of some unusual changes in the eye, and so when you look inside the eye, you find a clue about why the post-orbital septum might have evolved.
This long-tailed macaque found in Asia has a post-orbital septum, while the more primitive galago from Africa does not. The macaque's eye on the right has a circular black spot, The Galago has not. This is called a fovea, made up of many small specks, which are the photoreceptor cells. These detected light. The fovea is a part of the retina, where the photoreceptor cells are concentrated and is critical for sharp vision. A primate without a post-orbital septum has fewer photoreceptor cells, which tend to be widely scattered. Modern primates have far more. The sharpest eyesight is crucial for a tree-dwelling primate. On a computer, Dr. Ross simulates the differences.
The image is not as good as this. The image that they see with their eyes is blurry in comparison with what we see. So they're not as good at seeing fine details as we are. Whereas in contrast, an animal with a fovea, and so what you see here is the image around the periphery of the visual field is quite blurred.
When we visualize objects, we see the light reflected from them focused onto the retina. The more condensed the photoreceptor cells, the sharper the image. But even with a fovea, if the eyeball is wobbling in the skull, the image will be blurred. The importance of the post-orbital septum is that it holds the eyeballs firmly in place, so images are focused even when moving along branches. Vital for a tree-dwelling primate.
So when you find a post-orbital septum in the fossil record, that suggests that those animals had a fovea, and it suggests they had high visual acuity, perhaps the visual acuity of the degree that you see in living monkeys today.
There was another crucial component that eyesight would bring to a primate. As the climate cooled and the forests diminished, our distant ancestors would have needed good eyesight more than ever. Food would be getting harder to find. Competition would be stiffer. Early primates still visualized the world in two colors. Eyes have different types of receptors. Each is sensitive to one or more wavelengths of light. More advanced primates developed the ability to see in three colors. The forest turned green, a crucial advantage for finding food. As the forests retreated, fruits became scarce and many primates turned to eating leaves. Trees tried to stop this by adding toxins. Fresh new leaves were there for the taking, so long as you could pick them out. These red leaves are the fresh ones, tender and juicy. Seeing color has its advantages. Then eyesight moved evolution along another step, but in a way which was unexpected. Gorillas, chimps, proboscis monkeys, and others belong to a group called the arthropods. Like us, they have muscles which allow them to make facial expressions. Strangely, this was to push the evolution of primates even further along the path to early humans. With good eyesight, primates like chimps can detect slight variations in expressions, something which is important when you start to live in social groups. A chimp must be able to recognize other chimps from a distance, and they can do this because they can see in detail. At the Primate Research Center in Kyoto, Japan, experiments are carried out with chimps to ascertain how many facial expressions they can recognize. This is a greeting expression with rounded lips and the accompanying hoot. This one is happy, as he's just had a tasty snack. And this expression is fear. In the experiment, the chimp sits in front of a monitor where two different facial expressions are shown, along with a related call. When the correct expression is pressed to correspond with the call, a beep tells the chimp he's got it right. They get it right most of the time. With developed eyesight, primates could read emotions and build social bonds. Part of the journey towards becoming human on the miracle planet. If the oceans were the cradle for early life, then Africa is the cradle for humanity. Climate change has had a huge impact on our evolution. As the continent of Gondwana broke up, India began to move north faster than the other land masses. It collided with the Asian continent, forcing up the mountains of the Himalayas. By 7 million years ago, they had reached around 5,000 meters, 16,000 feet. This was when hominids began to appear in the fossil records of Africa. In summer, a strong upcurrent of dry, warm air rises into the sky over the Himalayas. The dry air blows down to Africa. From being wet and rainy all year, Africa began to have distinct seasons. The Sahara Desert started to encroach on the forests. As the forests vanished still further, grasslands opened up and early humans were faced with extinction. To survive, they were forced to alter their lifestyle. 2 million years ago, there were at least 2 species of hominid living side by side. That evidence was found in the southern tip of the African continent. Fossils from 4 million years ago to recent times are buried in layers. This area has been recognized as a UNESCO World Heritage Site. Sometimes it's called the cradle of humankind. Dr. Francis Thackeray of the Transvaal Museum is an expert on early human evolution.
We have remarkable deposits which are between 1.7 and 1.5 million years old. And in these deposits we have 2 species. We have Paranthropus robustus, an ape man, and early Homo, living side by side.
It was always thought that there was only one hominid species at this time. To find that there were 2 came as a shock. And perhaps also a shock to realize that even then, early hominids were starting to come to terms with technology. The 5 scorched fragments are burnt bone. Early Homo had mastered fire, the only species on the planet to do so.
People were using fire in this cave environment about 1 million years ago, and were using the fire in a controlled manner in a confined environment. What's important about this is that it represents perhaps the earliest evidence in the world for the controlled use of fire. It's an important technological step. We say that without the controlled use of fire, it would not be possible to have a rocket. And without a rocket, you could never get to the moon. So, in a sense, this represents the small technological step that led to the giant leap of lunar exploration.
The fires may have burnt for early Homo, but there was nothing he could do about the climate.
That was a time period of global cooling as well as drying, and eventually the tropical forest would have contracted and retreated northwards towards the equator. That was a time period when Australopithecus africanus evolved into other forms, potentially. That's one model. And Australopithecus africanus could be considered a distant ancestor, certainly a distant relative of these two forms.
The two different hominids, Robustus and early Homo, began to go their different paths. They chose different diets. Robustus seems to have mainly been eating tubers and vegetables, like this one that Dr. Thackeray is digging for. The plant is called Hypoxis. Probably very similar plants were here 2 million years ago.
Good. It's very clear that Robustus would have been eating plant food such as this, these underground sources of food. There is a lot of carbohydrate in here and a lot of good nutritious food. In Robustus, in addition to the very large molars, we also have the very large temporalis muscles that went down to the lower jaw. We can say that that was likely to be an adaptation for eating coarse, fibrous food.
There are other hints to the diet of Robustus. Examination of fossil teeth show many rough patches, perhaps from grit, while the teeth of hominid fossils are smooth. The divergence in diet had a major impact on human evolution. Early Homo chose to eat meat. Dr. Henry Bunn of the University of Wisconsin studies modern hunter-gatherer societies to get a glimpse of the past. Recent bones with cuts from modern hunters, when compared to marks made on fossil bone 2 million years ago, are remarkably similar, showing us that both were cutting meat from bone.
The other kind of modern study that provides invaluable insight for understanding the patterns that we see at ancient archaeological sites involves the study of modern hunter-gatherers or foragers, as they're called, such as the Hadza. The Hadza society provides a particularly relevant example in that they live in a Rift Valley lake basin environment that's not that different from what seems to have characterized parts of Eastern Africa 2.5 million years ago.
The Hadza people of Tanzania have not moved with the modern world. They still live the simple life they have for generations. This group, which is studied by Dr. Bunn, has about 15 people living together in 3 families. As with most hunter-gatherer societies, the women collect the roots and other vegetables and fruits. The tubers being dug out are probably no different from those dug by Robustus nearly 2 million years ago. The men are the hunters, but they will often track carnivores like lions or leopards who have made a kill. They either scavenge for the carcass or, acting in a group, drive the cat away to steal its prey. When the meat is cut from the bones, the Hadza use knives, where early Homo would have used flints. The principle is the same. Meat is the preferred diet now as it was then.
2.5 million years ago, there's food out there. There's high-quality food out there, and we want it. And one of the inventions that occurred at that point was the means to cut it off of a carcass or cut it off of a bone. simply because the hominins didn't have the physical size or the intellectual ability to really get into meat eating in a big way. The reason being, the challenge being that meat is a very hot item.
Competition for meat would have been fierce. Over 7 million years of human evolution, there have been at least 20 different species. Except for one, they have all died out. Forces deep within the planet were soon to impose change upon our early ancestors. The Great Rift Valley of Eastern Africa stretches 6,000 kilometers, over 3,500 miles. It's where Africa is still being torn apart today by tectonic forces. The planet itself has had a profound impact upon all life, and in more recent times upon the evolution of the human race. Inside the Earth, the temperatures are as hot as the sun. Sometimes the mantle rises closer to the Earth's crust. This is a recent temperature profile of the Earth's interior. It shows a powerful thrust is still rising under the African continent. But a few million years ago, the surge was even more powerful. Then the mantle lifted part of the continent and began to rip it apart, forming the Great Rift Valley. The regions near the rift became dry highlands, and the eruptions along the length of it created mountain ranges of 6,500 feet in height. The dynamics of the rift changed the vast grasslands into a variety of habitats. Dr. Elizabeth Vibra of Yale University thinks that these changes altered the lives of our more recent ancestors. This, she believes, was caused by the change in the grassland animals. Many grazing animals appeared with an increase in the number of predators.
Especially at these times when the Earth was cooling, the African environments were becoming more seasonal and more open, and hominids, various hominids, taxa were appearing. At these times, there was a huge influx of new species of carnivores. And there were far more carnivores around with our unfortunate early ancestors than there are around with us today.
There is ample evidence that early Homo, as well as eating meat, became meat. Moving onto the grasslands was probably forced upon early humans, but they began to gain the upper hand. The brain started to grow. This small brain belonged to an early plant eater. In contrast, this early meat eater grew nearly twice as big, while the extinct plant eater, robustus, remained small. The human brain consumes more energy than any other part of the body. Perhaps the high protein content of meat helped it to grow. Certainly, early humans needed their brain to help them survive and to live cooperatively.
Meat eating and brain expansion go hand in hand. One supports the other. If some hominin lineages had not begun to eat meat in a more significant way, then we could perhaps use the example of the robust Australopithecines as an explanation for where that might have led. They became extinct by 1 million years ago. So in a real sense, I think you could say with some qualifications, meat is what made us human.
Other human species continue to appear and disappear in Africa, and each time their brains grew even larger. One of our immediate ancestors, Homo erectus, had a brain larger than its predecessor. Homo erectus migrated out of Africa and spread to various parts of Asia. Their descendants traveled to Indonesia to become Java man. Then they reached China and became the Peking man. But both became extinct. Homo sapiens appeared about 200,000 years ago, and finally we made our first appearance on the family tree. Our brain had grown the largest of all surviving humans. It wasn't just acquiring a large brain which allowed us to survive. Another species had an equally large brain, the Neanderthals. They appeared about 300,000 years ago. Their brain size was exactly the same as ours. In body height, they were also about the same, but slightly more robust. Neanderthals migrated to Europe in the middle of the Ice Age. They were a hardy race as well as being good hunters. But they are now gone from the miracle planet, and we remain. From archaeological evidence, it seems that both Neanderthal and Homo sapiens shared very similar abilities. In this part of southwestern France, there are many Neanderthal sites. The Réjourdu prehistoric site was discovered by chance while the landowner was digging in his garden. There are Neanderthal remains here from 70,000 years ago. Dr. Jean-Michel Geneste has researched this site. He knows that the Neanderthals had the technical ability to make and use tools.
Les données que nous avons sur l'outillage de l'homme de Néandertal montrent qu'il y avait à la fois des outils qui étaient très spécialisés et qui ne servaient qu'à racler la peau, et qu'à côté de cela, ils avaient des outils un petit peu à tout faire, selon les moments, et qui servaient à couper les tendons, à faire de la boucherie, aussi à racler les peaux, et pourquoi pas aussi à tailler un bâton pour faire un épieu. Donc il avait une gamme d'outils très adaptée à ses besoins.
They hunted the large bison that roamed Europe during the Ice Age. Their sites are found all across the continent. Their population may have reached 500,000. Everything seemed set for success. Dr. Geneste even believes that they were capable of thoughts similar to ours. The skeleton of this Neanderthal is exactly as it was found. Perhaps evidence that they had thoughts of some afterlife and buried their dead.
Mais ce qui va demeurer, la grande particularité de l'Homo sapiens sapiens, c'est pas tant au niveau des techniques, il va développer des associations très complexes d'objets entre elles, c'est qu'il va développer des systèmes techniques, mais que dans le même temps, il aura aussi développé une culture dans laquelle il y aura une place particulière pour les images, pour la représentation figurative ou schématique. Et cela, on ne le connaît pas chez l'homme de Néandertal.
The two different species of humans seemed so similar, but what gave us the edge? there's an intriguing theory that might provide an answer. Dr. Jeffrey Laitman of New York's Mount Sinai School of Medicine compared the two skulls and then noticed a minor difference in the shape.
Groups like Neanderthals, and when you study the bottom of skull meat,
It was at the base of the skull. With Neanderthals, the central part of the base is flat, but in the modern human skull, it is rounded. The difference corresponded to the upper side of the throat, where the larynx or voice box is situated. As well as studying human skulls, he also studied living apes. They too had flat central bases in their skulls, just like the Neanderthal. Strangely, there is still a trace of Neanderthal in all of us, but it doesn't last very long.
remarkably, baby humans have the same configuration. So if you look at a newborn baby, its voice box is also all the way up in the throat, and babies always breathe through the nose and have the ability to breathe and swallow almost at the same time. Something remarkable happens in human development. Our voice box starts a journey down into the neck. Unlike any other mammal, we start in one place, but we end up in another. And that journey is very dangerous because it changes our entire neuromuscular coordination system. The changes begin in the early year of life and continue as we grow. As we get older, because we have a larynx all the way down in the throat, our airway and our foodway, which were separate in babies and which were separate in a monkey or a dog, are now crossed. And this is very dangerous. And this is one of the reasons we always get food stuck in our throat when we're trying to eat. And it's also one of the reasons why we have food that regurgitates. So we've lost out, but we gained something. By the larynx going all the way down in the throat, we get a large area of space above it, which can take the sounds that are produced inside the larynx at what we call the vocal cords or vocal folds, and we can modify them to a greater extent than that possible for any other mammal. We have thus gained the ability for fully articulate speech.
The two species had their larynx at different levels. The Neanderthal is on the left, modern humans on the right.
The flatness of their skull base tells us their larynx would be up much higher, and that their overall vocal tract would be very different than that which you find in living human beings. This tells us that Neanderthals could not speak the way we speak today.
When the larynx is in a high position, the distance from the mouth to the vocal tract is short. We let our voices resonate in the vocal tract. With a short vocal tract, Neanderthals would be limited.
The general ambience would be different. According to some linguists, they probably couldn't make certain of what we call the quantal vowel sounds, the ones we call in English oo, ah, e, the sounds in boot, father, or feet. It's highly unlikely that Neanderthals could make them, and with the same speed that we do. The hallmark of our kind is our ability to have fully articulate speech. This is what sets us apart from all other animals, and this is what set us apart from Neanderthals.
Modern science now has the technology to investigate down to the molecular level. Doctors Simon Fisher and Cecilia Lai of the Wellcome Trust Center in England have identified a gene that is involved with speech. It's called FOXP2 and is attached to the human chromosome number 7. They think this gene evolved more recently than 200,000 years, which would suggest that FOXP2 appeared after we had evolved. It might have improved brain functions that are used for language skills, but we don't know as yet.
We think that FOXP2 is a very exciting discovery because it clearly has had a dramatic impact on human speech and language abilities, but it's important to realize that this is just one piece of a bigger puzzle. But the great thing is that we now have a tool. We can use FOXP2 to find other elements of the pathway and of the puzzle.
40,000 years ago, Europe was experiencing the last peak of an ice age. In the north, the glaciers expanded and covered that part of the continent. In those conditions, perhaps it was language skills which gave us the edge over the Neanderthals. We would have been able to share information about the large migrating herds so we could plan ahead for the hunts and would be able to record the information we had gathered. It's thought that the marks on this bone might be a calendar of sorts. It was made by modern humans 35,000 years ago. We had started on a path that no other species had followed. These paintings on the walls of a cave in France show our ability to picture the world around us. We not only spoke a complex language, we began to transmit knowledge to future generations.
The essential difference between the Neanderthals and the Cro-Magnons appears to have been one of symbolic ability. The Neanderthals left behind themselves a very rich record of their material lives, but that record doesn't really contain much, if anything at all, that suggests a symbolic kind of existence, whereas the lives of the Cro-Magnons were literally drenched in symbol. The Cro-Magnons were us. They had all of those characteristics that we prize in ourselves today. They had painting. They painted fantastic art on the walls of caves. They did sculpture. They did engraving. They had music. They had musical instruments. They had notation. They had symbolic behaviors of all of the kinds that we associate with ourselves today.
Indeed, we have come a long way from those fires our distant ancestors lit in the African night. Dr. Ian Tattersall of the American Museum of Natural History believes it was complex language that allowed the development of symbolic thought, the communication of ideas and beliefs.
Language is more or less nowadays inextricable from our symbolic mental processes that allow us to understand the world in unprecedented ways and ask questions like, what if? We can pose questions like that and experiment with ways of dealing with the world and of exploiting the world in a more efficient way. And that is what I think sort of made Homo sapiens an unbeatable competitor when they came on the scene, and what ultimately led to the demise of the Neanderthals.
30,000 years ago, the fate of the two human species, Homo sapiens and Neanderthals, came to a crossroads. Complex verbal communication allowed Homo sapiens to share thoughts and ideas, to cooperate in the search for food and the struggle for existence. It was a struggle that the Neanderthals would lose, and there would be only one species left on the miracle planet. In a rural area in southwestern France lies one of the last Neanderthal sites. Immediately above the Neanderthal remains are those of Homo sapiens. Perhaps Neanderthals were driven away from their former habitat by the more capable modern humans, or perhaps the Neanderthals quietly left on their own. Whatever, 30,000 years ago, they died out. We became the last survivors. For the past 4 billion years, the pace seems to have picked up. Perhaps our mastery of language is taking us toward a new and faster process of evolution.
I think it is a fascinating point that language is a kind of second genetics. Genetics itself lasted for the first 4 billion years of life's history, and then quite suddenly, Darwinian evolution, genetic evolution, gave rise to creatures with big brains, which developed a second kind of genetics, which is language and the transmission of linguistic information down through generations. That gave rise to a second kind of evolution, which is called cultural evolution, which looks like genetic evolution in a superficial sense, but it's enormously faster.
And our lives have become faster. We live in an age when technology moves at a pace that perhaps we cannot stop. Our ability to communicate has at times transcended the message we are trying to send. What took decades now can be achieved in less than a year. And as each year passes, the pace increases. As a species, we now can influence the climate, just as microbes did in the early history of the Earth. We must learn the history of our planet, which has nurtured life for billions of years. Dr. Noam Chomsky knows that the choice for the future is ultimately ours.
This is a question of history, not evolution. And it's a question of culture and intelligence and sympathy and mutual understanding and mutual aid and support and so on. Those are capacities that we have. We know from our own history and experience that those capacities can be overwhelmed by other more destructive, savage, and cruel capacities that we also have. And the balance of these will determine whether the species survives in any decent form. And that's a matter of will and choice. There are no natural laws about this.
As a species, we are still held captive by the only planet we know that can support life. Science shows us that life was nurtured in the oceans of this planet soon after its birth, and that it matured through long ages of change. Finally, it spread out across the world. It diversified into myriad forms, most of which would fade away to become only a memory. After millions of years, a single species was to be the pervading force, but that could change in the blink of an eye. If we have learnt anything at all from our history, it must be that in the end, life prevails, and ultimately will be the victor on the miracle planet.